DeepTSF has been developed by ICCS in the context of I-NERGY as a general-purpose solution for automated time series forecasting. Said service has been useful for multiple pilots and use cases within the project. DeepTSF is meant to serve both data scientists and energy experts aiming to facilitate and coordinate their everyday time series forecasting tasks in an efficient and highly collaborative fashion. For the development of DeepTSF, a modular and microservice-oriented approach has been followed, consisting of several layers that assume different responsibilities and implement various functionalities within the application. In this context, the overall DeepTSF architecture consists of 5 layers that employ state-of-the-art programming frameworks. The first layer comprises the DeepTSF database. This is the I-NERGY MongoDB developed by engineering that enables direct access to the pilot datasets. The second layer entails the forecasting backend. This component is the core of DeepTSF and is responsible for extracting data from the database, pre-processing and harmonization in accordance with the specifications of the forecasting model input, model training and, optionally, hyperparameter tuning, model evaluation, and finally model storage and versioning. These steps can be executed either sequentially or individually. The third layer comprises the graphical user interface, which is the front-end environment of DeepTSF. It is developed using React, an open-source, widely used, and very well-documented JavaScript library, which offers versatility and unparalleled efficiency for building user interfaces. The fourth layer refers to the DeepTSF Workflow Management Platform. The latter supports 2 layers of workflow management that enable the execution of the forecasting ML pipeline. The basic workflow management comprises of a CLI that allows for executing, individually or sequentially, the required stages of the ML pipeline given parameters by the user. This CLI is developed on top of the built-in MLflow CLI. The advanced workflow management engine is based on Dagster and enables orchestrating, scheduling, and executing the ML pipeline through a user-friendly graphical interface. Dagster also allows to inspect and visualize execution logs. Finally, the fifth layer of DeepTSF is horizontal and refers to identity and access management. The latter are handled by Keycloak as the DeepTSF application has been integrated with the project's common security framework developed by Consensus. So, let us proceed to the demonstration of the DeepTSF end-user functionalities. This is the sign-in page of the I-NERGY load forecasting service. 3 user roles are provided by the service, namely a data scientist, an energy engineer, and an administrator. Aiming to demonstrate all of them, we are about to log in as an admin, as the functionalities of this role are a superset of the other 2 roles. This is the homepage of DeepTSF. A sidebar provides access to the various functionalities of the tool, which range from load forecast pipeline creation to experiment tracking and system monitoring. All of them are available to all user roles excluding the first one, which is limited to data scientists and administrators, as it requires modeling skills. Also, system monitoring is only limited to administrators. Let us first showcase this sophisticated functionality that allows the creation of forecasting machine learning pipelines in a graphical way. Here the data scientist can upload a CSV file of their preference containing a time series. Then they can select a variety of parameters to define the training procedure. As we can see, they can resample the time series to a different resolution as a pre-processing step, also selecting the respective aggregation method. Also, they can define the train, validation, and test set split. After that, they can set the name of the experiment in MLflow under which the specific pipeline will run. Then they can select a machine learning or deep learning algorithm along with a desired set of hyperparameters. Finally, the forecast horizon can be set as it is necessary for the model evaluation process. For the specific needs of the I-NERGY pilots, a second menu allows for similar modeling procedures. However, this time the dataset is not manually uploaded but is directly fetched from the I-NERGY storage. The pipeline can then be triggered and the data scientist is prompted to the MLflow experiment tracking interface to inspect its progress and detailed results. The MLflow experiment tracking interface can be used to visualize ongoing and finished runs within the specific experiment typed by the user. Additionally, there is access to hyperparameter values and the trained model per se, alongside evaluation metrics, plots, and other artifacts. Alternatively, the data scientist can trigger an experiment using the Dagster Workflow Manager, which allows for more detailed inspection of the execution and its logs. Similar to the main DeepTSF front-end, experiments can be triggered through the Dagster UI, and then the results are logged to MLflow. This feature is experimental and will be further developed and upgraded in the upcoming versions of DeepTSF. Let us proceed to the experiment tracking functionality of the I-NERGY load forecasting service. This functionality is useful for energy engineers that need a quick overview of a specific experiment, as the first tab lets them fetch the best model that has been found within a specific experiment by evaluation metric. The user also needs to select a number of samples that they wish to include while visualizing the forecast versus reality plot. The user then gets a summary of the model's performance in terms of various evaluation metrics, alongside the requested forecast versus reality plot that acts as a visual model evaluator. A second tab allows to examine the models of a specific experiment by entering the run ID of its respective evaluation stage. Finally, the System Monitoring tab gives the users an overview of the application regarding the available resources in terms of memory, CPU, and GPU, if available in the machine. Therefore, it allows them to monitor the workload at any time. A profile dashboard is also provided, including user data and available roles. In the end, a Sign Out button allows the user to exit the application. Thank you for watching this video. Join our network to find out more about I-NERGY project.